Good evening, all. I welcome you all on the behalf of StudyIQ IAS English. My name is Pritesh Maturkar. I welcome you all to this exemplary journey entitled Geography Through Maps, where I, as your friend, philosopher, mentor, and personalized tour guide, will take you all to a world tour. And in this world tour, we will be using the most potent tool of analyzing the world, of picturizing the world, that is maps. Geography as a discipline has been heavily reliant on using maps because any discipline will require some tools. Any discipline will require some of the methodologies of understanding it. And maps being the primary tool for analyzing the world, they become the basics of mastering the discipline called as geography. Okay. Through this series, guys, I tend to achieve two things. Number first, that you should all understand the basics of geography. So my lectures will roughly cover 50 to 60% of your basic GS discourse. Using this, you will be able to move ahead in understanding your advanced level GS concepts too, so that in this lectures, if you follow me, this being a continuing series, so you and me in this journey will make sure that even you get some of the advanced level concepts of geography. Okay, so 50-60% of your basic GS discourse will be taken care of in this lectures only. So treat this as the preparatory course for your ongoing syllabus, the syllabus which will eventually cover up in your GS classes. And most importantly, through this series, I intend to cover roughly 15 to 20 marks in prelims and roughly 100 to 200 marks in mains. Okay, and if essay comes in your purview, guys, then it's like God has given you everything. So using this knowledge only, you will be able to write essays and you will easily score at least 200 to 400 marks in mains. So this will be the utilitarian value of all whatever I will be teaching you through these sessions. Okay, good evening, Saurabh. Okay, and I intend to achieve second most important thing. I intend to achieve, that is how you can utilize maps for supplementing your mains answers. So this is the first time that I am taking you all into this territory. Up till now, we didn't discuss how you can utilize maps for supplementing other answers too. But using the knowledge of Atlas, using the knowledge of maps, you can even supplement your answers of GS paper 3, sometimes answers of GS paper 2 also, and of course GS paper 1. So we will try to achieve that also. So in every lecture, what I do is, in first 5 to 10 minutes, I tend to revise whatever we did in the previous sessions. Then next 15 to 20 minutes or roughly 30 minutes, I introduce you to new concepts. And then we try to apply those concepts on the Atlas. So that is the typical kind of journey which we have in these sessions. And then thereafter, I also try to paint current affairs for you all. So a holistic journey in 1 hour. And this being a continuum series, so we will continue this journey for a little bit now. And I hope that each and every one of you who joins me in this journey will greatly benefit from it. Okay. And as promised, guys, I am always starting a lecture with one of the entries that I've discussed in the previous class. So good evening, everyone. A formal welcome to you all. Okay. So let's begin our today's discussion by seeing one of the most beautiful national parks in the world and seeing one of the most beautiful locations of the world. So what you see on the board now, what you see over here is basically the redwood forests of California. The trees which you are seeing over here, so the trees are basically the tallest trees of the world. They are called as the Sequoia redwood trees. They are called as what? They are called as the Sequoia redwood trees. And these trees, they achieve height of more than 90 meters, of more than 80 meters. So these trees become some of the tallest trees of the world, and you have the world's tallest tree in a part of California. It is called as the giant redwood sequoia plant. Okay, so see how beautiful the topography is. I intend that all of you who watch these sessions, all of you who are being with me in this journey will go through these locations someday and will also take me. So I will be your guide too. Okay, so just see how beautiful this is. And once you see the beauty of this, now let's move ahead to our discussion. So let me just quickly introduce myself. My name is Pritesh Maturkar. My name is Pritesh Maturkar. I will be your primarily faculty for handling the current affairs, for handling the discipline called as geography, and you can reach out to me on a Telegram channel. You can reach out to me on Telegram by just joining this channel called as Geography by Pritesh Maturkar. What you can do is you can do a global search entitled at Geography by Pritesh. So if you just do this, a global search on Telegram, you will be very easily able to connect with me. And on this channel, I keep on posting on a daily basis the important tidbits of geography, the important aspects which are evolving as of now. And I also share some of the important PDFs which are important from prelims perspective as well as from the mains perspective. And using those PDFs, guys, you will all be able to cover at least 100 to 200 marks in your mains part and at least 15 to 20 marks in your prelims discourse. So it's my humble request, please join me on this endeavor. So it is entitled Geography by Pritesh Maturkar. You can just search at Geography by Pritesh. Okay, now let us begin our today's session by quick recap of whatever we did yesterday. So yesterday I did introduce you to some of the most difficult aspects of geography of the world physical setting. So yesterday I ventured out into the discussions of two things. So I ventured out into the discussions of the vegetation and the climate, vegetation and the climate of the mid and high latitudes. Okay, mid and high latitudes, so upwards of 50° north. So the weather of this, the climate of this will be heavily reliant on what? It will be heavily dependent on what? It will be heavily dependent on the formation of fronts per se. Okay, fronts, what are fronts basically? So fronts are those areas where air masses of contrasting properties come and interact with one another. So you have what? You have the cold Arctic air which is coming from the poles, and you have the warm Saharan tropical air which is coming from Sahara, which is coming for Atlantic, and all of this will meet at roughly 60 to 65 degrees north. And here, because of subpolar low pressure belt, you will have intense mixing up of this air, very much atmospheric instability, and hence you will have rainfall which is scattered throughout the air, pretty much scattered. But in the winters you will have snowfall because the temperatures will dip below zero, and hence over here you have one continuous belt of vegetation called as the taiga. So you have one coniferous belt stretching from the west coast of Canada to east coast of Canada, stretching from west coast of the Eurasia. Okay, Eurasia in the sense the Europe too. So you will have Norway, Sweden, Denmark, and it will stretch across the entire Central Europe, and you will also have the Russia, the Siberian Russia, where you will have this coniferous belt. So this was one of the most delicate aspects of discussions of the vegetation in that latitude. And then I also introduce you to a topic or to a subtopic wherein how do the local orogeny affect the vegetation, and how do the local orogeny will result into topographical changes. So you must be remembering that we discussed that any mountain will have a orographic side, and if that orographic side is resulting into obstruction of moisture laden westerly winds, so on the orographic side you will have a phenomenon called as temperate evergreen rainforests. And on the leeward side you will have what? On the leeward side you will have grassland. So I didn't discuss grasslands yesterday because we will venture out into the grasslands when we will do the detailed analysis of every continent. But for now, just remember guys that on the orographic side you will have dense temperate evergreen rainforest, whereas on the leeward side you will have grassland. Okay, and hence we saw some of the good examples of this. So the photo which I made you all see just before the beginning of this lecture. So on the west coast of USA you have which mountains? You have the Rockies, you have the Pacific Northwestern complex, and hence you have obstruction of westerlies, you have the redwood trees. Similar thing happens on the west coast of South America along Chile. So along Chile again you will have such forests, and in Africa you won't have such forests. Why? Because there is no land there present in that latitudes, whereas New Zealand in one of the best representation of that forest, In New Zealand rather guys, we have mangroves. Okay, so this is very extraordinary, this is exemplary. Okay, rather this is one of the wonders of the world, that in New Zealand you have mangroves outside the equatorial and outside the temporal belt. Okay, so that is the thing that happens. So now guys, let us move ahead our discussion today. Okay, let me just paint a picture for you with regards to the polar vegetation and with regards to whatever happens in the mid latitudes. Once we are comfortable with the understanding of the mid latitudes and of the polar latitudes, then we will slowly divert our focus, will slowly divert our attention to the understanding of the surface of the earth, and then slowly I will move into the hydrosphere, the oceanography, but on a very basic level, on a basic preliminary level. So whatever knowledge is needed for me for going or for taking you all on a world tour, so that knowledge I'm covering first, so that when we'll go on a world tour, all of the things will come in handy. Okay, so I hope that everyone is enjoying this world tour. So now let us again focus on some of the important aspects with regards to climate of the polar regions and the climate of the mid latitudes too. Okay, so now just quickly let me just quickly reopen the world map for you all. So two things I will be discussing with you all today. The first thing that I will be discussing is the vegetation of the polar areas. Let me open up the earth for you all. Okay, so this is the earth. Okay, so if now I'm zooming in on the polar areas for you all, so these are our polar areas. Okay, we are basically moving above the Arctic Circle. We are basically moving above what? We are basically moving above the international tree line. Okay, so let's say this is 66.5 degrees north. So as soon as you cross this tree line, you will have what? You will have no trees, and there will be no trees. Why? Because the sun's rays will fall at a very slant angle, and as the sun's rays have to travel through a greater amount of atmosphere, the sun's rays will diffuse, they will scatter, and the total insolation received, even though it is same on the upper levels of atmosphere, but as the insolation scatters while it falls over the polar areas, hence you have very diffused sunlight on the polar regions. If I'm trying to paint you all a picture, so if I draw the earth and if I explain you the concept again, so please get this concept again. Okay, so let's assume this is our earth. Okay, so if I am showcasing you the sun's rays, so on the equator the sun's rays will fall perpendicularly. So this is the perpendicular receipt on the equator, whereas as we move towards the poles, let us assume this to be the axis of the earth. For now I'm assuming the earth's axis to be straight, okay, just for our reference. So as we move from equator towards the poles, see the angle. Okay, see this angle 90 degree, whereas this angle is highly acute. This angle is highly acute. Okay, it's highly slant. So because of this guys, what happens? Because of this, what happens? As the angle is slant and as you have a surrounding atmosphere around the earth, so as the angle is slant and as the rays have to travel through a greater amount of distance in the atmosphere, the rays, they start to scatter, they start to disperse even more. So what you have at the polar locations is very diffused sunlight. It is very diffused sunlight. Okay, so diffused sunlight, it is basically the zone of twilight. Okay, and you all know that at the polar areas, for the 6 months you will have darkness, and for 6 months you will have sunlight. And mind you, that sunlight is how? That sunlight is very diffuse sunlight, so you won't have sun shining as bright on the equatorial areas, on the tropical areas, as compared to the poles. So the sun will shine over there, but the sun will not be as bright. Why? because the angle of the sun's rays, it becomes very slant. And number two, as the sun's rays have to travel through greater amount of atmosphere, they tend to scatter, they tend to disperse more. So now because of this, what happens, guys? So as the sunlight receipt is less, so you won't have big trees over here. And also because you have extreme cold conditions, as the conditions are extremely cold, this region is called as permafrost. This region is called as what? This region is called as permafrost. And as this region is called as permafrost, it's permanently frozen. So there will be extreme water stress too. This is called as permafrost, permanently frozen. And here you will have extreme water stress too. Okay, extreme water stress. So because of this, the vegetation you find over here, the vegetation which you will find in these areas will be very short. It will be very thin. Okay, and that vegetation will predominantly be adopted for surviving in the harsh winters. So any vegetation which can survive beneath layers of ice, that kind of vegetation you will find in this part. And the vegetation that you have, it is called as what? Anybody who is watching the series live with me, you are free to comment. The vegetation which you will find in this part of the globe, it is called as tundra vegetation. Okay, and the representative of the tundra vegetation, so the vegetation that you have in this part, it is called as tundra vegetation. And the representative vegetation of tundra being mosses, very small mosses. You will have lichens. You will have lichens. And the representative vegetation being rhododendrons. Rhododendrons. Okay, rhododendrons. Rhododendrons. So this is the representative vegetation of the polar areas, mosses, lichens, and rhododendrons. If I'm showcasing you this on via image, so let us open up the images also, so that you get a bird's eye view. Okay, you all get comfortable. Okay, let me just search for tundra vegetation. Okay, so if you see the images of this, okay, so if you see the vegetation in the tundra areas, so see, if you can see on the board, okay, very small vegetation, very small grass, okay, small flowers. These are called as mosses, these are called as lichens, and these are basically the areas where you don't have very big trees, you have very small grass, very small lichens, and the representative vegetation being the rhododendrons. So this is how you have the unique representation of the tundra areas. Okay, if I'm opening up the image, this is how you have the image of this. Okay, let's see this image. Okay, now here you will be able to see the image properly. So this is the image which you see in the polar areas, in the taiga, in the northwards of taiga areas, particularly the tundra. So as you can see, the height of the vegetation is very less. Okay, you have very small mosses, lichens, and you have these flowers, rhododendrons. Okay, and all of this is specially adapted to survive in the harsh polar winters. So just imagine that this all now getting covered underneath ice. So these trees are specially adapted to survive underneath the ice, and the animals of these areas, particularly reindeer. Okay, so reindeer do what? They dig up the ice and they survive on this. And as I already told you guys, if you consider the Lapland region, okay, if you consider the Lapland region, if you consider this region of the world, okay, this region, okay, if I'm showcasing you all this region, if I paint the picture of this region for you all, this is called as the Lapland. In Lapland, Now, because of climate change, the reindeer population is dwindling to its lowest extent. Okay, and because of this, the local people over there are suffering, because for them, reindeer is the most prized possession. They use every body part of reindeer in some or the other way. Okay, reindeers have been used for riding from one place to another. So you must have seen Santa Claus. So Santa Claus has got reindeer in front of his cart. So they are used for transportation. They are sometimes even used for little bit of agriculture and pasturing. And if the reindeer is very old, it is curled, it is used, every part of reindeer is used as meat, as food, okay, even as wearing of its skin for protection from the harsh winters. So this region of the world is now historically suffering from climate change. And if you want to really see climate change, you should go northwards of the tree line, because here climate change is affecting the most. Okay, for the first time, guys, Lapland had what? Lapland had ice-free summers for the very first time in 2021 and 2022. 2023, it's not yet clear, but for the first time, 2021 and 2022, you had ice-free summers over here. Okay, so this is a very dire warning for the humanity. This is a very dire warning for us in a all. Why? Because we are pumping more and more carbon into the atmosphere. We are it is resulting into what? Basically, it is resulting into more heat trapped, and as the more heat is being trapped, you are having global warming, and because of global warming, climate is changing. So please make sure that you are comfortable with this area too. So this area will have vegetation which is predominantly mosses, lichens and rhododendrons, and the animal kingdom which was surviving on this, it is now facing increased difficulties. And because of ice-free summers, so the polar bears, the leopard seals, okay, the Arctic foxes, now they are having a very difficult time to survive in these summers. Okay, because as the ice melts because of global warming, the habitat is changing. So just assume this, guys, that you have your own habitat. Now because of something, your habitat is changing completely. So you have to survive to the changing conditions, you have to adapt. So now the burden of climate change is exorbitantly falling upon the Arctic areas and also upon the Antarctica. Antarctica is also experiencing historic melting of ice. And the burden of the European luxury, the burden of the Western Californian luxury is now falling on the polar areas. So guys, this is not at all done. We need to do something. So today I will also explain you what is the link of pumping more carbon in the atmosphere and its impact on global warming and climate change. So once we do the mid-latitudinal parts of the globe, so I will introduce you to that concept, and then we'll shift our focus to the Earth's lithosphere per se. Okay, so now let's move ahead. So I hope the vegetation of this part is clear to you all. Now I want each and every one of you to focus very carefully on this part of the world. Okay, the mid latitudes. Okay, if you see the mid latitudes of the world, okay, first of all I'm showcasing you on a 3D globe, then I will move you all to showcasing on a 2D globe. So see this part, okay, this part of the world, okay, this is the mid latitudes. Okay, these are called as what? These are called as mid latitudes. Okay, so mid latitudes, you will find this land predominantly in Asia. Why? Because Asia is the world's biggest landmass. Okay, if you go towards North America, so if I move towards North America, so basically in North America you have the Rockies and you have the Great American Plains called as prairies. So you don't have that much landmass scattered as compared to Asian landmass. See, I'm again fitting this line very properly over here. So this is called as the mid-latitudinal belt of the world. And why I'm predominantly saying you this belt? Because this belt is away from the sea. See, if I'm marking you all the nearest water bodies, okay, big ones, okay, so this is very far away from the Indian Ocean, this is very far away from the Mediterranean Sea, this is very far away from the Arctic Sea, and this is extremely far away from the Pacific Ocean. So no big water body to influence the weather and climate of this part, and also you don't have any mountains over here of that significance. You do have local hills, you do have local hillocks in this region, but if you consider this region is fairly away from the big water bodies. You do have water bodies like this is the Caspian Sea, this is the Black Sea, but comparing the size of land and the sea, these are fairly small water bodies. So this land, this mid-latitudinal belt of land is away from the Indian Ocean, this is away from the Arctic Sea, this is away from the Pacific Ocean, and it is also away from the Mediterranean Sea and the Atlantic Ocean. So there is no water body to moderate the temperatures. Please understand this very properly, guys. What do you mean by temperature moderation? Okay, so you are living on a land which is close to sea. So if I consider coastal locations, what will the sea do? Sea will moderate the conditions. How so? Because water vapor will evaporate over there. You will have rainfall. Even the water in the daytime, you will have breeze which is flowing from land towards the sea, because in the daytime the land will warm up more. You will have low pressure on land, whereas on sea you will have high pressure. So sea wind will move from sea towards the land, so you will have sea breeze. In the night time it will again reverse, you will have land breeze. So if you go on the coastal areas, you have periodic diurnal winds called as land breeze and sea breeze. So the conditions on the coastal areas are little bit moderated because of presence of the vast oceans along the shorelines. But as you move away from the oceans, as you move towards continental location, please mind this word, as you move away from the oceans, as you move towards continental locations, what happens? So such kind of location is landlocked in the sense that I'm not talking that whether it does have access to sea or not, but landlocked in the sense of it's having a close water body which is of big scale to it. Okay, so this part is particularly landlocked with regards to the access to big seas. So this water bodies cannot influence or cannot moderate the climate and temperature of this area. And this being a perfectly continental locations, I'm again reiterating, guys, this being perfectly continental locations, the climate and weather of this particular location, it becomes continental. What does the weather of this part becomes in the world? It becomes continental. Now please understand the continental kind of weather. So now I'll be using a 2D map for you all. Okay. Okay, so I'm zooming in on this part of the world now, the mid latitudes of Asia. Okay, so I'm focusing on the mid latitudes of Asia for you all. So this is our mid latitude. Okay, this part. Okay, so this part is away from the sea. This part is a perfect continental location. This part is a perfect continental location. Okay, so what will happen? It is away from the sea, as it is away from any of the moderating conditions. It is away from the polar ice caps, so you don't have cold water vapor or cold waters reaching this part which will tone down the temperatures. Neither you have warm winds which will reach from Africa in this part, this being relatively isolated. So the continental locations of the world will have two things. Please understand this very, very properly. The continental locations of the world will be characterized by two things predominantly. Number one, they will have extremities in weather. They will have what? Extremities in weather. Okay. Extremities in weather means what? What do you mean by extremities in weather? That in summers, the temperatures will cross well above 40 degrees Celsius, whereas in winters the temperatures will rarely cross above 0 degree mark. I'm again reiterating, in summers the temperatures will cross well above 40 degrees Celsius. Okay, so you have certain locations in the Central Asia where the temperature does go 42, 43, even 45 degrees in summer, whereas in winters exactly opposite happens. You have temperatures well below 0 degrees Celsius, well below the freezing point. And why this is happening? Because there is no water body to moderate the weather and climate of this location. So you have extremities in the weather and climate. And the second thing which these locations are basically characterized with, okay, so because of these extremities, the vegetation over here, the ecology over here predominantly becomes grassland topography. Okay, you have the grasslands, okay, and you also have deserts if the rainfall is very scanty. So you have grasslands and you have deserts in this territory. Okay, so if I tend to present you the grasslands or the deserts, so some of the best grasslands of the world, or rather the grasslands which support roughly 30% of Europe's grain intake. I'm again reiterating, guys. If you get this point, you will very much enjoy the war which is going on between Russia and Ukraine. Okay, I'm making a very big statement, this being an open platform, so you need to understand the war of Russia and Ukraine from this angle. Okay, so let me add up another window and let me just add up another earth for you all so that I can have even more detailed discussion on this. Okay. So if I'm considering this part of the world, okay, I'm focusing on the mid latitudes of Asia. Okay, this part again. So this part of the world has got some of the best grasslands of the world, and these grasslands, they are called as the steppes. These grasslands are called as the steppe region. Okay, so the steppe region, it extends from east of Ukraine. So this is the river Dnieper, which is flowing through Ukraine. So the steppe region starts from over here, it flows through Kazakhstan like this. So here you have some of the world's best grasslands, some of the world's best fertile territory for agriculture, called as the steppes. And what do these steppes support? Steppes support roughly 30% of Europe's grain intake of wheat. So 30% of Europe's wheat production comes from this part of the world, which is called as the Ukrainian steppes, the Kazakhstan steppes. So you have Ukraine, you have Russia, and you have Kazakhstan. Okay, so you have the steppe region bordering the Russia and Kazakhstan border, and it extends up till east of Ukraine. Okay, so this complete part of the globe, this is called as the steppe region. I will discuss this in detail when we'll do the Eurasia part, but now just understand this. I told you that this region will be either characterized by grasslands or it will be characterized by deserts. Both of them have geostrategic and geopolitical significance. Okay, so the steppes are very important for Europe's wheat production. So the first thing that Russia did as soon as it attacked Ukraine, I don't know how many of you know this, but the first thing which Russia did as soon as it attacked Ukraine was that it basically siphoned off, okay, it basically stole roughly 350 million tons of wheat from the eastern Ukraine. Okay, so this is very astonishing, guys. Why? Because you all know, because of climate change, the Siberian part of Russia is now no more going to be habitable with regards to agriculture, with regards to local industry. So Russia knows this, that in future agriculture is not going to be supported in Russia anymore. So the first thing which Russia did was that it siphoned off 350 million tons of wheat from the Ukrainian steppe region. And most of you must be thinking that the war which is happening in Russia and Ukraine is because of the war of NATO and the war with Russia, or the war between dollar and economic war. But food security comes above all. Food security will dominate every other security of the world. If you are not able to feed your population, then you cannot exist as a nation. So Russia knows this, that in future we need to be dependent on the Ukrainian steppes, on the Kazakhstan steppes for our wheat part, for our grain part. So the first thing that they did is doing this. And this is the bigger vision of that once the fertile steppe region comes in our purview, so we can even extend our agriculture too. We can expand our agriculture, we can increase our agricultural production. Okay. So you don't have to see the ongoing war between Russia and Ukraine from only this angle. You have to see the ongoing war from the steppe angle too. Okay, so this is a very interesting information tidbit that I can share with you all. And the region to the east of steppes, the region to the east of steppes. This is called as the Central Asian deserts. This is called as the Central Asian deserts. Central Asian deserts. Okay, so the 5 sthans of the world, you have Kazakhstan, Tajikistan, Turkmenistan, Uzbekistan and Turkmenistan. So the 5 sthans of the world, they are basically the Central Asian deserts. You basically have flat topography. Okay, you have very small grass, very short grass, less than 1 meter. And what this has basically translated into, so all of the 5 sthans were once under USSR, Union Soviet Republic of Russia, so the United Soviet States of Russia. Okay, so it was one big communism umbrella, okay, communist umbrella of the world. It all disintegrated in the year 1989. But once USA detonated its nuclear weapons on Hiroshima and Nagasaki during the ending of World War II, precisely 1945, so Russia used the Central Asian deserts. I'm again reiterating, Russia used the Central Asian deserts as its nuclear test bed. As its what? Nuclear test bed. Okay, Russia detonated some of the biggest, some of the most destructive bombs, hundreds and hundreds of tons powerful than what was detonated in Hiroshima and Nagasaki by USA. Okay, so there is a very famous name of the bomb called as Tsar Bomba. Okay, it was roughly 900 times more powerful than a detonation in Hiroshima and Nagasaki, which Russia detonated in the Central Asian deserts. So the Central Asian deserts again have a geopolitical significance, that they were used as nuclear hotspots or nuclear test beds by the Russia. Okay, and if you go today to this region, guys, if you go to the 5 sthans of the world, it's a very sad thing that is happening over here because of this nuclear testing. Okay, the percentage of people born with disabilities, the physically disabled persons, are very high in the 5 sthans. Okay, why? Because of the nuclear fallout, because of the nuclear radiation, you have persons with inborn disabilities being born in this region on a very large scale. So if you visit the hospitals of these areas, you will find numerous people born with either physical disability or mental disability. So the Central Asian deserts do have a geopolitical significance and history, and basically these deserts are the sole territory connecting east, west, north and south. Okay, so recently you have a very important news of Uzbekistan. So Uzbekistan's president has won a very astonishing referendum to rewrite the constitution. Why? Because Uzbekistan was once a part of the Soviet Republic. So Uzbekistan president will now rewrite the constitution. It will give good rights to the people, and you all know whenever constitution is rewritten, what will happen. Okay, so this part is also geopolitically not that stable. And just to the south of that we sit, hence India needs to have a very watchful view over the 5 sthans. Okay, the ongoing SCO dialogue, you have Shanghai Cooperation Dialogue, which is now going on in Goa. Okay, so this is very important from the safety and security of this region. Okay, the geopolitical history of this region is not good. And why this has been used as nuclear test bed? Because of its geography. So guys, geography does shape history. Geography does influence the future of any country. Okay, so please remember this, guys, from 2 parts, that you will have extremities in the mid latitudes. Why? Because of their continentality, as they are far away from the moderating areas of the big oceans, big seas. So you don't have any moderation in the climate. So in the winters, the temperatures will drop well below the 0-degree mark, and in summers the temperatures will move well above the 40 °C mark. And secondly, you will have deserts, you will have grasslands, and the war which is going on in Europe per se, the Russia-Ukraine war, you please interlink that war from the angle of food security. Okay, so I hope that those who are watching me live, okay, some of you are watching me live, So I hope that this is an interesting tidbit to you all, and that you are now enlightened as to how you should perceive the world, as to how geography shapes history, and how history will also indirectly be dependent on geography. So should geography be studied historically, or should history be studied geographically? So this is called as the chronological dimension, where do we study geography historically or should we study history geographically? So both of them are interlinked. Okay, so very fascinating kind of entry. Okay, so we did the polar areas, we did the mid latitudinal areas. Now we are left with the eastern temperate regions. We will not focus on the eastern temperate regions as of now, because it is little bit more technical, so we'll be needing even more knowledge for that. So for now, I am now discussing the last part with regards to the climate, which I think is important from climate change perspective. So after this, we will diverge into the understanding of the Earth's surface. How do you have mountains? Where do you have trenches? Where do you have the plates of the world? What are the major plates, minor plates of the world? Okay, what is their movement? Okay, how do you have the present orientation of Earth per se? So we'll move into the basic aspects of that. Then I will move you all to oceanography, and then we will start our journey of world tour. I'm already taking you on a world tour. I'm making you comfortable, but then we will move at an aggravated stance. So I intend to cover up your entire atlas through these sessions, and in that I will be also covering roughly 50 to 60% of your GS discourse too. Okay, so now let's move ahead to the discussion of a thing which is climate change. Okay, because you will see this everywhere in the news as of today. You will see this issue burning everywhere, and this issue will keep on burning for days to come, because we are now all living in the era of climate change. So for this discussion, I will be needing some of the basics of the atmosphere with you all. Okay, so today I'm enlightening you with regards to the composition of atmosphere per se. I won't go into the details of it, but I will be just discussing some of the major gases and some of the minor gases of the atmosphere, and what role do greenhouse gases play in the Earth's atmosphere. Okay, so if you consider the Earth's atmosphere, so what is atmosphere basically? If I'm painting you all a one-line definition of atmosphere, so what is atmosphere basically? So atmosphere is nothing but a envelope of gases, but a envelope of gases, envelope of gases which surrounds the earth, but the envelope of gases which surrounds the earth. Okay, which surrounds the earth. Okay, and it makes life possible on earth. It makes life possible on earth. Why? Because it makes us available the gases which are important for biological processes like respiration and photosynthesis. So you have gases like oxygen, you have gases like CO2. You all know oxygen is important for respiration, and CO2 is very important for photosynthesis. So this is very important for respiration. Okay, and this is very important for photosynthesis. So these gases are predominantly provided to us by the atmosphere. Okay, so a very crude definition of atmosphere: it's like an envelope of gases which surrounds the earth, and it makes life possible on the earth by providing us valuable gases like oxygen and CO2 for respiration and photosynthesis. Okay, now what is the composition of this atmosphere? Okay, so in atmosphere you have three major components. You have major gases, you have minor gases, and you have water vapor and dust. So if I'm painting you the composition of the atmosphere on a very crude scale, on a very elementary scale, what is needed for us for understanding of the world's physiography and how climate change is basically altering the world's physiography. So let's discuss that. Okay, so the composition of the Earth's atmosphere. Okay, the composition of the Earth's atmosphere. Okay, on a very preliminary scale, if I'm considering. Okay, so first you have the major gases. Okay, you have major gases. Okay, in major gases, roughly 78% you have nitrogen. You have nitrogen. Okay, Then you have around 21% oxygen. Okay, then you have carbon dioxide, and you also have a gas called as argon. You have carbon dioxide and you have a gas called as argon. Okay, so the concentration of carbon dioxide is less than 1%, and the concentration of argon is also less than 1%. Okay, so both of these gases, they each account for less than 1% of the oxygen. You have another gas called as minor gases. Okay, I'm giving you guys a very predominant understanding. Okay, very predominant understanding of the Earth's atmosphere. You have minor gases. In minor gases, predominantly you have ozone. Again, its concentration is less than 1%. In fact, it is less than 0.001% too. Okay, you have ozone. After that, you have a gas called as helium. Okay, you also have a gas called as helium, and you also have a gas called as xenon. So these are the minor gases of the Earth's atmosphere. And you also have water vapor. You have water vapor and you have dust. Okay, so you all know, guys, the concentration of water vapor and dust will be dependent on what? The concentration of water vapor and dust will be dependent on how much saturated the air is, or how much moisture is present in the air. So if we go to the equatorial areas of the world where you are having heavy amount of rainfall, so there you will have more water vapor in the atmosphere. Whereas if you consider that hot Saharan deserts, if you consider the hot Australian outbacks, so there you will have winds blowing across deserts, it will pick up the dust, so there the dust concentration will increase. So the concentration of water vapor and dust in the atmosphere will be dependent upon which latitude you are considering. So the major gases, the minor gases, water vapor and dust. Now let us assume the role of carbon dioxide, or let us assume the role of the greenhouse substances and gases. Okay, so guys, please understand this very properly, okay, because this is highly technical and I want each one of you to get this concept here and here itself, what is basically global warming and how it affects climate. Okay, so the life which is possible on Earth is why? Because you have a average ambient temperature being maintained on Earth. Okay, so you have the average ambient temperature, maintained on Earth. Okay, average ambient temperature maintained on Earth. You have average ambient temperature maintained on Earth. Okay, and who is maintaining this temperature? This temperature is maintained by the greenhouse gases. It is maintained by the greenhouse gases and the substances. Greenhouse substance gases and the substances. Okay, why? Because they have the ability to trap heat. They have the ability to trap heat. Okay, they trap what? They trap heat. Okay, so if you are having insolation of the sun, okay, you have greenhouse substances and gases. The insolation will strike the surface of the Earth. The insolation will revert back, and as it reverts back, it will be trapped by the greenhouse substances and the gases. Now, how this happens? This is extremely important. So again, now focus on this. Okay, whatever insolation we get on this Earth surface, so the insolation or the sun's rays on the Earth surface which we get. Okay, so imagine this is the Earth's surface. Okay, the sun's insolation is predominantly short wave high energy. It's predominantly short wave high energy. Okay, this is the predominant insolation which is incident on the Earth's surface. Okay, so this we called as the electromagnetic radiation. Okay, this we called as the electromagnetic radiation. Okay, so what will electromagnetic radiation include? Electromagnetic radiation will include the gamma rays, it will include the X-rays, it will include the ultraviolet rays, it will include the visible spectrum, and it will include the infrared. Okay, so this is the EMR spectrum. This is the electromagnetic spectrum. You will have gamma rays, you will have X-rays, you will have ultraviolet, you will have visible rays, and you will have infrared. So this is the electromagnetic spectrum which is incident on the earth. Now out of this, please understand guys this very properly, out of this, the gamma rays and the X-rays, they are predominantly absorbed by the magnetosphere of earth. You all know the earth behaves like a giant magnet, and because of that you have a magnetosphere around the earth. Why it is, how it is, we'll drill into it in little lectures. But the gamma rays and the X-rays are predominantly absorbed by the magnetosphere of earth. Okay, so these rays don't reach the earth's surface. Just imagine if we don't have magnetosphere, gamma rays and X-rays would have incident been on our skin and we would have completely ionized. So life on earth would not have been possible. So the magnetosphere of earth plays a very important role in absorbing the gamma rays and X-rays. Okay, the UV rays. Okay, the UV rays are predominantly absorbed by the ozone in the earth's atmosphere. Ozone you predominantly have in stratosphere. Okay, I know these things are a little bit technical, little bit difficult, but just understand this, that you have a layer in the earth atmosphere called as stratosphere. Okay, I know all of you must have heard this name, that you have ozone in stratosphere. Infrared is not of any consequence. And atmosphere, the earth's atmosphere is largely transparent to the visible spectrum. Okay, atmosphere is largely transparent to the visible spectrum, is transparent to the visible spectrum of earth. Okay, visible spectrum means the VIBGOR, the 7 colors of the rainbow. Okay, so what you see in the world, basically, when the eyes, what your eyes perceive, the eyes perceive the incident rays. So the atmosphere is largely transparent to the insolation received from sun. With which spectrum? Only the visible spectrum. Rest of the spectrum is either absorbed by magnetosphere, it is either absorbed by the stratospheric ozone, and infrared is not of any consequence. So what you see the world is basically in the visible spectrum. So the colors which you see, the blue color which you are seeing on your screens of my jacket, okay, the whiteboard, the black marker which I'm using, why this is happening? Because the atmosphere is largely transparent to the visible spectrum. Had it been the case that the air in this studio would not have been transparent to the visible spectrum, so you would not have seen my beautiful skin color. Okay, jokes apart, but okay, so why this is happening? Because the atmosphere is largely transparent to the visible spectrum. And mind you, how is this spectrum, how is this energy incident on earth? It is short wave high energy. It strikes the surface of earth, earth will absorb some of it, and earth will reflect it back. Now whenever the earth will reflect back the energy, whenever the earth will reflect back the energy reflection is always long wave, less energy, long wave, less energy. Why? Because earth will absorb it, earth will work upon it, and then earth will reflect back. And what do the greenhouse substances and gases do? Greenhouse substances and gases will trap this outgoing long wave, less energy. Okay, so now what is happening, guys? We are pumping more and more carbon in the atmosphere. We are pumping more and more greenhouse substances and gases like carbon dioxide, like methane in the atmosphere. We are also pumping CFCs, chlorofluorocarbons. So now, as the concentration of these gases will increase, what will happen? More and more heat trapping will increase. Why? Because the more the carbon you will pump, the more it will trap the heat which the earth is giving out. And the earth is giving out heat in the form of long wave and less energy, and these gases are very good in trapping the heat and as we pump more and more gases, more heat will be trapped, and as more heat is trapped, it will result into what? It will result into global warming. It will result into global warming, and global warming will result into what? Global warming will result into climate change. So it is not that climate change is causing global warming, guys. It is exactly opposite. Climate change does not result in global warming. Global warming is resulting into climate change. And why this is happening? Because the increased pumping of greenhouse gases and substances in the Earth's atmosphere is basically resulting into more heat trapped. Okay, so the average ambient temperature of Earth was approximately 15.1 degrees Celsius before the pre-industrial levels, before the industrial revolution began in UK. Now it is roughly warmed up approximately 1.1 degrees Celsius more as compared to the pre-industrial levels. So this is a very daunting kind of thing, and guys, understand this very properly. Okay, so if I am considering the composition of Earth's atmosphere, the greenhouse gas of carbon dioxide is accounting for less than 1% of the Earth's atmosphere. Now just assume this, that if its concentration increases by more than 1%, if we pump more and more carbon, what it will result into, what warming it will result into. So two things very important, that the atmospheric gases which are capable of trapping heat, the greenhouse substances and gases, they account less than 1% of the Earth's atmosphere, and their ability to trap heat is resulting into what? More and more heat trap as we pump more and more carbon into the atmosphere, and hence because of this we are having global warming, and because of global warming we are getting what? We are having climate change. We have climate change, and this climate change is manifesting differently at different places. This climate change is manifesting differently at different places. Okay. So in tomorrow's lecture we will see how the climate change manifests in different places and how does it manifest, and then we will begin understanding of the topography of the Earth's surface. Okay, so tomorrow's lecture again is going to be very paramount lecture. Those of you who are watching me, please understand this properly, and those of you who will join me tomorrow, I hope that you will revise everything and you will come. Okay, so I'm again reintroducing myself, guys. So my name is Pritesh Maturkar. Okay, you can reach out to me on a Telegram group, on a Telegram channel called as Geography by Pritesh Maturkar. Okay, the name of the channel is Geography by Pritesh Maturkar. You can just do a global search @Geography by Pritesh. You can join me in this endeavor where I keep on posting the relevant tidbits. But tomorrow it will be an eye-opening lecture for you all, because here I will manifest the climate change different at different places. How climate change it manifests. So please make sure that you come with everything prepared, whatever we have done. Okay, thank you Simham, thank you Rohit. Yeah, the content which I'm giving is of course from your perspective, wherein I use this content to support your preparation. So it's my endeavor that I give you the best quality content which you can directly apply in your examination. Okay, so see you all sharply tomorrow at 5 p.m. where I continue my lectures. And guys, please make sure that you have Orient Black Swan with you once I begin the understanding of maps per se. It's my sincere request. If you have Atlas, it will be a very eye-opener for everyone. Okay, so on the behalf of StudyIQ IAS English, I thank you everyone. Have a very warm night. Study hard and smart. Okay, please remember this. You have to study hard and smart in civil services examination. See you all on the other side, everyone. Please take care. Bye-bye.